Ada versus Autogen. When it comes to coding, which should you use? So I think a big problem with the incredible fast pace of developments with large language models and tools built upon them is they sort of swim around in our brains all together as if they're families of the same thing, when they can be quite different from each other. So the example of Ada and Autogen comes to mind. We have this fantastic tool that I was talking about in a previous video that I have now, it's become my go-to when I'm either writing new code or evolving existing code, is to use Ada. Ada is an entirely command line based type in the change you want and it will make that change kind of tool. That's really, really useful and very quick. And one of the unforeseen advantages of it is it forces me quite quickly to understand how to take what I want to do, compress it into a sentence, and in so doing I end up solving a lot of the logical things that I hadn't actually solved when I was imagining what new feature or capability I wanted to add into the code base, because I want to instruct Ada correctly, and in doing so I'll simplify the problem down to something that it can actually be implemented. Now, this has been around for a little while. I think I said in a prior video, I think I saw this from Matthew Berman's video about it, and ever since then I've been using it. It's perfect for me because of the kinds of sizes of projects that I'm doing. They're usually complex, as in have a lot of files, but they're not usually massive code bases. There's no huge production stuff that I'm dealing with. It's normally a small little tool program set of scripts that I'm dealing with. Previously I was looking at lead enrichment tools that I was making, and I used Ada to do that. But shortly after I discovered about this, I also discovered about Microsoft Autogen, which came out, actually it was only back in September. Everything here in AI land is moving so fast with these large language model tools that it's really easy to forget that this was only a couple of months ago. So Microsoft dropped this. It took a little while to make its way onto YouTube because of other news and other things that were going on, but essentially this is a framework with which you can easily implement I wanted to say agents. I'm not really sure that's the perfect way of talking about them. Calls to large language models that retain some history of their conversation, that you can use this framework to have them talk to each other or in a group. Example here is this conversable agent with a user proxy, a user agent proxy that will be a go-between between you and the agent that it's speaking to, and run any code that comes back, other stuff like that. Because there's that element about running code that comes back and using it to solve problems with code, I think there was at least in the initial coverage on YouTube that I saw, there was a confusion about the purpose of Autogen. At least in my mind, it can make code. I don't think that's the whole purpose of Autogen. I think that underestimates how broad a framework it is. And also, as a result, because it is a broader framework, that doesn't mean it's particularly tightly focused in on coding the way a tool like Ada is. So I think that's the sort of major difference between the two. And this might explain some of the confusion. In the documentation that came out with it, the very top chunk of examples are all to do with code generation. You've got automated task solving with code generation, executing and debugging. It is kind of magical to use Autogen to say, I want a script that does this. It codes it, it tests it. If it's wrong, it sends it back and says what the problem was. It evolves it, it codes it, it tests it, and when it works, it gives it to you. It is quite beautiful to watch. It's nice to be able to give a requirement and then wait and be fairly good at trusting that it's going to come back with a good result. Fantastic. Both of these tools are designed primarily to work with OpenAI, Azure or otherwise, because that is our leading large language model right now. GPT-4 is brilliant at structured, reasoned problems, and it's quite the best at producing working code first time around. So that's generally what these tools use by default, and you can change them to use others. However, this might illustrate what some of the problem with that is. If you think about each specific model as being a different kind of brain, same idea, same intent to be able to answer your query with good working code, but a slightly different brain. Not necessarily always a problem that they have different capabilities. If you're going to go backwards and forwards anyway, maybe it takes a few more iterations to get it right, that's fine. But perhaps the problem is more how you phrase the question to start with is going to differ, as if they had different personalities. Not really suggesting they're different personalities, but there's certainly differences in prompts that you would give to GPT-4 and expect to work well, and prompts you would give to a Llama 2 based model and expect to work well, especially when it comes to coding or reasoning, which is really stretching the capabilities of these models. Something GPT-4 is good at, something the Llama 2 models not quite so good at, or may need more careful prompting to get the best out of them. So here's an example of some of the code. I've gone into Ada to sort of find one of the examples of what kind of prompts under the hood get sent to that large language model. And you can see you've got quite a long one here. This is for editing blocks. Act as an expert software developer, always use best practices. These are nice short sentences. I like that. They feel like they're instructions. It feels like the model is more likely to have been trained on data that understands how to act after it's received a short sentence instruction like that. Okay, and then we've got a list of things it must do. I suspect a list format's really the smart way to do it. I think the way humans interact with lists is they are treated like a checklist. Each thing must happen. Therefore, I imagine as a result of being trained on that kind of data and tested with human feedback on that kind of data, these models will have been taught to go through numbered lists and hit each element. Other more complicated and wordy parts of contexts may get skipped, lost, or deprioritized in the output when it figures out what's the probable best thing to say. So you may find some of these things at the top don't actually get done every time. In fact, usually with the context, as I understand it, it's the middle half, or early to middle half. The beginning and the end seems to be dealt with well. So a list is a good idea, but also putting the most important things at the top and at the bottom, they seem to be understood to be good ways of making sure that the LLM acts on that information. But yeah, this is quite a long prompt, and there are some examples. So it's is it one example, two examples? So it's few shot prompting. Essentially, it's being given the idea, it's being given a couple of examples, and then at the end of this, it's going to have the remaining actual prompt for this turn to be inserted there. This will produce slightly different behavior and results depending on which model it's sent to for the completion. Ada has been developed to work well on GPT-4, and although I see they've recently got GPT-4 Turbo, I think that's not a massive jump. You can expect that that will have similar behavior, so that will be except being faster, better, cheaper, etc. So this is quite tightly bound to the model that it was developed with. Every little tweak that I can't see unless I look at the blame history for this file that made it perform better was an effort in tying it down to working with that specific model. That's fine. In fact, they're very clear about it in the documentation. Don't expect Ada to work anywhere near as well with locally run open source models because it was developed to work with GPT-4 and GPT 3.5. And here, they've got a whole section on this. Can I use Ada with other LLMs, local LLMs? There's a big conversation in the Discord about it. I had another look today, and yeah, the conversation is always coming back to the same thing. It's saying, nearly, not quite, there's this problem, there's that problem, because it's not developed as tightly bound to that, or rather it has been developed tightly bound to GPT-4, and therefore won't perform so well. But you could put the massive effort in, but then you go into the problem of which of the many open source LLMs do I pick? There's a whole plethora of them. There's a whole section on Ada which I think is instructive on the Ada website, talking about the benchmarks, and this is illustrative of how different each model is, although they're only talking about the GPT ones here, and what the results are on the attempts at changing code. And it's essentially, although this is quite a short article, it demonstrates that there was an extensive piece of research and development within the attempt to, within the development of Ada, before it was, released or in its early history, to make sure that these things worked, coming to some architecture decisions. So the edit formats are different for each model. So if you're going to have to edit a whole file, then GPT 3.5 seems to work well. If you're going to do a diff, then GPT-4 seems to work well. If you're going to do a whole function, diff function, so depending on your use case, you may want to rely on a different model for the best performance cost trade-off. And when you're developing a tool like this, it's going to leverage those large language models, then you do want to get the best bang for your buck. And so you will develop something that is tailored for now, and the model's available now and works well now. And as future models become available, then maybe it will not need to be so tightly bound. But for now, that's the result. That's the reality. Which is why when I come to tools like Super AGI, I'm hesitant about how effective they are going to be when we want to use local models. Now, I want agents to work well. I want agents to be able to handle complex series and flowcharts, and flowcharts that are inferred by the loose context of a situation where I want it to take on a problem and solve it start to finish. I want that technology available. That would be great. What a time saver. However, right now, if I use a tool that uses GPT-4, it's quite expensive. I know the price has gone down recently, GPT-4 Turbo, I believe. So yes, it will get cheaper. And lots of people with enough pockets to put investment in and get started right away, well, they'll just go use GPT-4 and later it will get cheaper and faster, and that's fine. But for me, I would like to be able to use local LLMs. I also have certain privacy concerns about the data I might be putting in there, whether it's okay, whether it's ethical to push that data out via APIs. And so I want to be able to use open source local models hosted. But then I have the problem of how tightly bound is my solution to the model that I'm using. If I am going to take an existing, quite deep architectured thing like AGI here, like Super AGI, there's quite a lot of structure to it. I think one of these, yeah, here we are. This is just an overview of the structure. Probably that's fairly general. It's probably only as detailed as it needs to be to achieve a general outcome. But the more structure that you put on top, then oddities that may come out of new large language models may persist and percolate through that system, causing bigger issues. And I don't want to have that problem. You can see here an example of one of the prompts that's in Super AGI, and it's fairly long. And I don't mean massive, but what I mean is there's quite a lot of requirement for reasoning in here. So you solve complex problems. Obviously, you'd expect reasoning to be something that Super AGI would need to lean on. But here are some things that I think are challenging. With no legal complications, I've yet to find any model that can navigate the complex logic of law. I don't really think that that's going to achieve anything other than not obviously wrong. But that's that's the kind of thing that we're asking, we're stretching these large language models to do when we want them to do complicated undertakings. We're asking them to reason, and not all LLMs can reason that well yet. So when we have a list of goals and then the instructions, this is obviously template content. Somewhere else in the code, these things get filled up. So it's going to be a bigger sort of list of elements than we can see on the page here. You have a list of tools, and there's sort of this sequence performance evaluation. Again, I think it's probably good that it's a list. It encourages that the result from a large language model is that each of those things will be considered. And then a request to respond only with valid JSON. I mean, that requirement alone has historically been really difficult with open source LLMs. The amount of poorly formatted JSON, failure to escape quotation marks and that kind of thing that's come out, it's huge. And that was one of the reasons I installed and then uninstalled Super AGI quite quickly when I first got started, was having that problem all the time. Infinite loops and poorly formatted JSON prevented me from sort of moving forward with it. And I look forward to this alpha level cutting edge software getting better, but that meant for me, not yet. I'll come back to it later. So yeah, so when they said 28 days ago, local LLM support is there, brilliant. But it was also followed by lots of people saying similar things to this. I've tried, it's not working, the test model failed. If I went to the Discord, it's still full of people who are struggling to implement that because it's alpha level software and it's new, and I understand, and that's life. So still, for me, not yet. I look forward to playing with it, but it's not for today. So there are a couple of differences between Super AGI as something with already a very specified structure to achieve agent-based outcomes, and a tool like Autogen, which is a framework within which you could hopefully fairly easily stitch together multiple large language model conversation threads in a certain way to have a similar effect. And I think the reason why I think this is useful is because you can tailor it to a specific use case that you have, not adding so much structure so quickly that you already have this kind of level of complexity to start with. When this is delivering well on a wide variety of use cases, then that'll be the first thing you do. But for now, I have hit too many errors for me to think that all that complexity that is the lofty aim of Super AGI is right just yet. And that was sort of echoed in a recent video that I saw from David Shapiro, where he was interviewing principal researcher Dr. Chi Wang from Microsoft Autogen, and there are a couple of real nuggets that I took from this. This David Shapiro is well worth following. I think it's fantastic content if you're interested in AI and large language models. This interview had a couple of really beautiful pieces. There was sort of an approach suggested, a couple of nuggets. One was, don't add so much structure. Start with as little as possible. Which makes sense. Well, firstly, it's obviously an engineering problem. But more than that, when we have large language models talking to other large language models, getting stuck in loops, saying the same thing over and over again, failing to reason and failing to progress is, I think, more likely. Whereas if you have, you can always start with one, try and get GPT in its most sort of automated form, as it's now capable of using tools and such to just solve it for you, maybe just with a ChatGPT subscription. That might do it. And many use cases might be as simple as that. However, the minimum suggested here in this video, which I think makes a lot of sense, is having at least two, where one is generating the solution and one is really critical of that solution, maybe running the code and saying it's wrong and sending it back. And so if the user's on the outside of this loop, they don't have to deal with the inside. a lot of the experience of, let's say, dealing directly with ChatGPT to write code and then copying it into your code environment and running it, and then it doesn't work, is then you've got to find the error output, copy it, and then paste it back into ChatGPT. And then it will no doubt solve the problem in 1 or 2 steps. It's fairly good at that. But you're having to do all the copy pasting. It'd be great to avoid it, and here's a way of doing it. Which again is one reason why I think Autogen was thought of as a, with that example, the magic could be seen, and it would go, great, fantastic, then we should use Autogen for coding. But I think that was an example. I think you could use it in something that would do coding, but Autogen is a broader framework for stitching together conversations, one-to-one, group conversations, all that kind of thing. I imagine Autogen will be really handy for instructing large language models to take on a persona of a board of directors and having a group discussion. The output would then primarily be language. I wouldn't be asking them to do too much logical reasoning and getting stuck. And you could end up with some great consensus ways forward, where you consult your fictional board. Something will be interested to implement at some point. But this idea of having someone produce and someone criticize it, or rather a large language model produce some code or a result or an output, and a large language model criticize it into loop until it passes some criteria, is deemed acceptable, I think is quite powerful. I think that's why the GAN image generators looked so amazing. That's the adversarial approach, I think, is really good for that. So that, I think, is a sort of minimum. However, Ada fooled me with its simplicity. And actually, I think it does this in the background, or at least some element of it. When I found these prompt details in here, I haven't read through the whole code, but I can see that there's some specific replies here where the system replies back. And I don't see these replies in the terminal. So this part here where it says, I ran this command and got this output, this is it automating that kind of step of here's the code, here's the output, and dealing with it. And so if that's in there in the background implemented, that explains a lot as to why Ada is producing really good working code first time round with only a sentence explaining the behavior I'm looking for. I don't get many errors. And even when I do, again, I can paste them into Ada and it will fix them, which is fine. And also the other major power of Ada is that it deals with complex repositories that already exist, because it uses universal C tags to understand a map of all of the functions and all the objects and all of the stuff and what it does, and figures out how to send that in an effective way to GPT-4 to produce the output. And it looks like to iterate on making sure that whatever comes out makes sense. I've looked elsewhere in the prompts. I can see there's other type bindings, such as knowing that ChatGPT is going to, or GPT API is going to come back with a certain format of Markdown. How do I strip all that stuff out so I'm only left with the code? All that stuff sort of written in there, which again prevents it from moving over to a large language model. But that's okay. I've done development with Ada, and it's not that costly. I think I spent about £8 last month on a whole bunch of stuff. And it enabled me to do an entire lead enrichment set of scripts, which I now leverage and use. It's really taken the length of time it takes to develop right down. So I'm not going to do it in this video, but in a video coming up quite shortly, I'm going to just use it live on a problem that right from the start, scratch an existing repository, and we're going to just evolve it. Install Ada, ask it to do it, see what it comes up with, run the result and see that it's worked. And you'll see how simple it is. It's, I think, just that little bit ahead of, say, GitHub Copilot. If you already had GitHub Copilot, then as you're coding, all these suggestions are coming in, probably helping massively. You can really see how it would. I don't have that, but that's okay, because I'm not writing in the code at that point where I want the help. I'm looking at my code base and I'm telling it the feature I want, and then it is doing it. And I think that's incredibly valuable. And if you're actively coding on a code base and you have to keep adding little features or making little tweaks, or there's a bug in the wild and you have figured out what it is and now you know the change, roughly speaking, you could write a sentence that explains the change you need to make. You can give that to Ada. And because it does it in Git, you can look at the commit details and inspect that it was right. Occasionally it's come up with things that have introduced errors, but if you can read code and ask Ada, it really is like pair programming. As the headline promise, it is AI pair programming in your terminal. It's fantastic. I say what it needs, it writes it. I can tell by inspection if it's made a small mistake, but they're rare. And if it's a big mistake or a bug that comes out in execution, it can fix it when you feed it back in. So I just wanted to end on this this piece that I found here. It's the only one I've managed to find. I was searching for a good way of measuring how good is a large language model at reasoning. If I wanted to take a big flowchart of stuff or a paragraph of explanation as to what I want to happen and have it come up with a plan or some code that implements it, it needs to be good at reasoning. Now, that is taking something and reflecting on it and planning. And it's not obvious that that should be a core competency of large language models at all, but they do have that capability, or at the very least GPT 3.5, GPT 4, they have that capability, GPT 4 especially. And I can't find many benchmarks that seem to look at that. Probably because it's quite complicated to benchmark. You can ask it to do things that large language models are strong at, and a human can figure out fairly easily did it do a good or a bad job. I imagine that's quite in depth if you're going to ask it to say plan a dinner date, for example. Those kinds of things that are just the plan will be in natural language and short. Most large language models pretty good at, but it can get complex quickly the more context you have. If you give it a massive context and then say I want to plan something using that, then you probably expect that that will work because you've experienced asking OpenAI's models, and there it works. But that's not that common. And one of the big problems when you try and use a smaller open source model is you find it doesn't have that capability. Its reasoning goes off really quick. And that's probably because OpenAI has invested so much time and money in people assessing whether it's made a good result, and so helping to fine-tune that model to be even better. And of course, you know, a huge data set to start with, all very costly stuff that the open source models haven't had the same budget. So I found this one, LLM RGB. It's not one of the ones on Hugging Face, as far as I can tell. It's not massively famous, but you can see what the prompts are, which is quite useful. So you can, well, the general thing here, I'm looking at reasoning depth in particular, multi-step reasoning. If the answer can be inferred directly from the context, that's pretty easy. If it requires reasoning, it'd be greater. And you know, if you want to write a program using provided context, that's obviously the most in-depth reasoning, which is something GPT-4 is very good at. And you can see this sort of ranking here based on their scores of the various models. Llama 2 is quite far down, and most of the open source stuff is based on Llama 2. Fine-tunes can, of course, improve that, and I think many have. But there is a big gap. And you can see some of the specific kinds of questions here on this one. We have some, like, here's a trip plan. That's one where there's a giant context, lots of information about things you can do, and you're asked to plan, the large language model is asked to plan a trip. And GPT-4, GPT 3.5 and Claude 2, both, you know, all brilliant at it. Less so for the open source models. Much less so. Llama is actually pretty good at that one compared to some of the other things it falls down at. So you can see here the kind of question that it struggled with. A requirement check, code completion. Obviously, there are fine tunes on coding specifically. I don't think that this is the chat version, so not the code version. So it would make sense that these came later. But yeah, so you get an idea about some of the open source models not having the same reasoning skill that GPT-4, GPT 3.5 and Claude 2 have. And I was struggling to find this because, of course, this is basically what people are saying on Reddit and Discord and various other places where people talk about LLMs in practice, their experience using it. They aren't getting what they want out of open source models. And when they turn to ChatGPT and paste their prompt into there from their code, they get a great answer, and they're perhaps disappointed that they don't get the same kind of level out of out of open source code. But that's the reality of dealing with it right now. I think there are some brilliant open source models. I have been using Mistral locally. It's been really, really good. But I tend to keep my request limited. I don't tend to want to stretch it to deep reasoning. GPT-4 is great at that. I want to give it things where I think a small model run locally will be good at that. And if I want it to do multi-step, maybe I need to supply the architecture that helps it perform the reasoning. And that's where I think Autogen can come in. So no, I don't think Autogen is the right answer for coding. Maybe something based on it way down the line, but I think that work has been done with the best model that we already have, and that's Ada. So for me, in practice, right now, no competition. I use Ada. I use it on every code base now. I will use Autogen for its service as a framework to allow me to do complicated things according to the architecture that I decide, using local models, because I really want something that performs complex outputs, is not tightly bound to costly APIs, and is private, secure, and local. And I'm really looking forward to developing that with Autogen. And I can imagine I'll use Ada to help me do it. I hope you found that interesting. The next video will be me using Ada, so you'll be able to see it in action. That's it. Catch you next time. Bye.